Here I'm going to talk to you about the area under the curve, or AUC. It's useful because it helps us to work out bioavailability. So typically what you would do is you would plot plasma concentration against time. Let's assume that this is in hours to make it, and this is in milligrams per litre. And what you would usually find, of course, is you give someone a drug, goes up, then it gradually goes down as the drug gets eliminated. So you might do that after, in the presence of food. Sorry, no presence of food I'm talking about. So this would be oral. See why I had food on my mind when I said that. But then when you do an injection, you get you bypass much of the all the issues of absorption and stuff like that, and you end up with this area under the curve here, and we're going to compare that with this area under the curve for this one. So that area divided by this area equals F, the bioavailability. It's how much drug actually from what you ate or took actually ends up in the plasma or in the blood. Right, so how do we actually work these things out? Well, it doesn't matter how you work it out. There are several ways of doing it. Let's just think about what it is. First of all, what it actually represents. So, like I said, this is concentration, maybe in milligrams per litre, and this is time in hours. So if you work out this area here, it would be in the multiplication of those two. So it would be milligrams hours per litre, because it's milligrams over litre times hours. Milligrams over litre times hours. And so what does that actually represent? It's an index of how much drug that was pretty terrible writing, let's change that. It's an index of how much drug and how long in the plasma. And the way to work it out is there's several ways you could do it. As with working at any curve, what you can do is simply take, of course you don't usually get a curve, you get points. So you get maybe 0 there, you get a bunch of points like this. So one way you can do it is to simply plot these, if you like, as a histogram. I haven't drawn this very well, but you get the idea. A first approximation is going to be adding up the areas of all these. So you've got the height, and you've got the width here. So that's h times w, that's h, so it'd be h2, h1 times w, h0 times w, etc. But of course w is all the same, so this drug interval is a constant interval. So that basically means it's w times h H1, so this one here, plus H2, this one here, H3, to the last measurement. So in other words, it's that you add up, if you've got, so remember H here, each of these is the same as that. It's the actual concentration that you measured. So that means what you do is if you've got, say, T0, 10 minutes, 20 minutes, 30 minutes, 40 minutes, and you've got 0 here, maybe 5, so this is time, and this is concentration. You're measuring every 10 minutes, 5 mg per mil, 10 mg per mil, 10 mg per mil, 2 mg per mil. These are H. And the width of these rectangles here, this is the width, is these. So then all you do, a quick way of estimating it, and it is estimate of course because there's an error, is you add all these up. So 0 plus 5 plus 10 plus 10 plus 2, that's 27. And then times it by the width, which in this case is 10. So then the area under the curve is 270. Of course it is an estimate, as you probably spotted, because the actual line doesn't, does that. So you've got all these errors here. But do you know what? It's close enough. It's close enough. So that's how you work out the AUC. So let's just do it in practice. Let's imagine that we're going to put a drug. We're going to first of all put it in. Let's draw our axes. We're going to have two curves. We're going to have our injected one, which goes up straight away and then down like that. And we're going to have our oral one like this. And we want to work out the green one divided by the red one, so the yellow one, to get our bioavailability. Right, so we want to find out this area and this area, our two AUCs. Let's imagine a bunch of numbers then. We're just going to have 5 time points we're going to take. We're going to have time here. Then we're going to have concentration for when it's injected. And we're going to have, if I've got this right way around, concentration oral. 10, 20, 30, 40, 50. Let's say these values, this is injected, so we go straight up to 30, 15, 7, 4, 2. Nice exponential. I'm cheating. When we do oral, we get 0, 5, 10, 5, 1. So let's add all these up. 2, 4 is 6, 13, 28, 58. This one, 10, 21. So now our AUC area under the curve is 58 times the interval here, which is 10, equals 580. And here is 210, 21 times 10. So then, bioavailability here is 210 divided by 580. (210) divided by 580, just typing into my calculator, otherwise known as Google, is 0.36. Or 36%. So that's how you use area under the curve.